Good afternoon. Today we are going to finish off the theory regarding eccentric buckling. As important is that how come? I have uploaded homework 2. Okay, if you go to homework 2 is uploaded. Okay, it took me quite a while. It's because even though if I post it earlier, you'll still not be able to do it because we are still teaching eccentric buckling. Okay. From yesterday's note, I forget to, is it yesterday or Monday? If you look on my Monday notes, term test 1, February 4, 6:30 to 9 p.m. 3 questions for homework 1 and from homework 2. Okay. And you also need to know the examples from the lectures. Okay, because I can pick lectures questions also. Are we clear? Okay, so you're going to get 3 questions. Okay. When I say homework 1 and 2 for now, because I don't know how fast I can teach, okay, for now, if I can cover quick enough, homework 3 might be coming in. Okay, we don't know yet. Okay, but I'm always in agreement that less is more. So yesterday, we read out that Y max is equal to secant P L over 2. Okay. So note that we know that small p is equal to square root of what? Square root of capital P over EI. So therefore, our Y max term will have E, right, secant. And now we replace P with square root P over EI. And we write this down, L over 2, the whole thing in the bracket, minus 1. Okay, that is your Y max. Okay. Now, we also know from yesterday, what do we know from yesterday? We also know from yesterday, we have proven, if I can find it. We also know, hold on, I'm looking something that currently I can't find. Right. We also have shown that P critical is equal to pi squared EI over L squared. Or we can express the term EI is equal to P critical L squared over pi squared. Okay. So I'm going to write over here, note that EI is equal to P critical, right, L squared over pi squared. So from here, we know that Y max is equal to E, right? And we wrote this as secant, and then we have a bracket, then we square root P. We replace the EI with PCR L squared pi squared, okay? And then multiplied by L over 2, the whole thing minus by 1. In this form, we can cancel the L, okay? And the final form of Y max will be E secant P over PCR. And then we have the term pi over 2 outside the square root. And this is minus 1. Please be reminded that whenever you see this formula, it has to be in what? Radians. Okay. You all know how to change your calculator from degree to radian, yes or no? Yeah, you're good to go. Good. Okay, so always remember, throughout my years of teaching, students forget to change this to radians. Okay, this is very important. Okay. All right, so now we have formulate our Y max data or Y max equation. Okay. So the only term that you're not sure over here is E. So the rest of the term you should be very familiar. Okay. So E over here, just a quick reminder, is our eccentric distance or is eccentric load distance. Okay. Later we come into that when we start doing examples. So now, if we were going to calculate the maximum stress, right, that the structure is taking on due to eccentric loading, this will be equal to P over A, plus by M maximum divided by I multiplied by C. I believe you have seen this formula before. Okay. So now when we write this, so this equation over here is always for buckling. Okay. Why I say this equation is always for buckling, by right, the formula to use should be like this. Okay. But because we know it's buckling, we understand that the stresses is in compression. Okay. Now, what is this C? Okay. So C is the distance furthest away from the geometric centroid. I will show you how to find these values. Okay, I will show you how to find this value. Okay. So in order to compute Mx, so Mx will be equal to P multiplied by Y max plus E. Okay. So if I were to go to the notes yesterday's notes, we have this diagram. We'll bring the diagram here. Okay, this diagram. Okay. So as you can see this diagram, this counter moment over here, MQ. Okay. The first moment we have to react is we have this PE, which belongs to here. And the next one is at where? Y max. And Y max is occurring at point Q. So from here, we realize that we can write back stress max is equal to P over A plus by P multiplied by Y max plus by E, and then the whole thing divided by the I multiplied by C. Okay. So now we would like to factor out P and A. So P over A will be 1 plus by A multiplied by C divided by I, and then you have Y max plus E. Okay, we have this expression. So basically, I factor out P over A. Okay, that's why we introduce A at the numerator. And this is a good thing. Okay, why this is a good thing? Because note that I is equal to AR squared. Okay. And then if we go further, we know that I over A is equal to R squared. So therefore, to simplify our expression, we have stress max will be equal to P over A, 1 plus by C over R squared. And then we have Y max plus E. So we're going to rewrite or expand this form. So this will be equal to P over A, 1 plus by C over R squared. Knowing that the Y max value, right, we have the Y max value as E secant. Okay, so I'm going to write up the Y max value. So E secant. And we have square root pi over 2 square root P over PCR. We close our bracket. Okay, sorry, I have to look at the formula. I can't remember. And then we minus E. Close our, not close our bracket. This belongs to Y max. Then we have plus E, and then the whole term closes. Okay. So we know both E's can be cancelled. The final form that you can see, this is equal to P over A plus by EC over R squared secant. No, I don't think I need to put a bracket down here. So secant pi over 2 and square root P over PCR. Okay. So over here, stress max occurs at point Q. Now, I've posted the homework and some solution or the solution use a different form, but it's the same formula. Okay, so now I like to highlight what I mean. Okay, so in the homework, you can see the solution.